This lesson is going to deal with adding and subtracting radical terms. But before we do that, let's work from a familiar example. So if we were asked to solve 5x plus 3y minus 2y plus y, well, the first thing that we do is we realize that we need to go looking for what are called like terms. All right. And we know that like terms have two properties that we're going to check. We're looking for the same variable. So in this case, we'll notice that the x in the 5x and the x in the negative 2x, they match. They're the same variable. And these variables, the base, must have the same exponent. Okay, so this x is raised to the exponent 1, this x is also raised to the exponent 1. These are like terms. So the 5x and the negative 2x, they can be combined. Similarly, the 3y and the positive y, they can be combined. So we would write our solution as 5x minus 2x is 3x, and 3y plus y is 4y. And that is our solution. We'll notice in our final answer that we cannot combine the 3x and the 4y. Well, why? Well, because they are not the same variable. It fails that first test that we are doing. Okay, well, how does this help us? Well, let's consider this question. If we were asked to solve 5 root 2 plus 3 root 7 minus 2 root 2 plus root 7, well, look at the similarity between this question and the original one involving the x and the y's. You can see that if I take this term and this term, these have the exact same terms within the radical signs, that is, the 2. Now, how does that help? Well, what we're going to do is we're going to consider these not to be like terms, but they are going to be like radicals. And the check for the like radicals is they have to have the same value inside, and they have to have the same radical sign. And what do I mean by the radical sign? I mean that they both have to have a square root, or they both have to have a cube root, or they both have to have the fourth root. So the sign, that is the type of radical sign, has to be identical. Okay, so that means that we have some like radicals here. And just as I was able to combine the like terms above, I can also combine the like radicals. So I'm going to write them right beside each other. I'm going to say this 5 root 2, well, it can be combined with the negative 2 root 2 because they are like radicals. The plus 3 root 7, well, that can be combined with the plus root 7. They are like radicals. Adding them together, well, just as we added 5x and we subtracted 2x to get 3x, well, 5 root 2 minus 2 root 2 is 3 root 2, and 3 root 7 plus 1 more root 7 is 4 root 7. So just as 5x plus 3y minus 2x plus y is equal to 3x plus 4y, we've got the exact same sort of pattern happening here, and our final answer is 3 root 2 plus 4 root 7. Okay, let's look at a harder example. What if we were asked to solve this expression? Well, at first glance, you might look at the various radicals, and you might say, well, we've got a root 2, a root 3, a root 18, and a root 12. And we say there aren't any like radicals there, so I can't combine anything. And I'm going to suggest that you take a little bit of a closer look at the root 18 and the root 12. When you see larger values like this, you don't want to be too hasty, because what's going to happen is you're going to find out that you can actually combine these together. So the root, or negative 3 root 2, and the 7 root 3, those mixed radicals cannot be reduced any further. Notice that the root 2 and the root 3 cannot be reduced. However, if I look at this root 18, I know, and I'm not going to go through the whole process of writing out the factors, but I know that that is the same as 9, a perfect square, times 2. And similarly, the root 12, well, I know that a perfect square is 4, and that's 4 times 3. How does that help us? Well, negative 3 root 2 plus 7 root 3, and then if I take out the root 9, that's going to make this 15 in front, because it'll be 5 times 3, the square root of 9, root 2. Similarly, root 4 is going to result in a 2 coming out of the radical sign, making this negative 6. And now I can see I've got some like radicals. So let's go ahead and combine them together. The first radicals I'll look at is these two here. So I've got minus 3 or negative 3 root 2 plus 15 root 2. So that's going to be equal to positive 12 root 2. And then I'll take a look at the root 3 like radicals, and I'll combine 7 root 3 minus 6 root 3 is positive 1 root 3, and I typically will not write the 1 in front. So we were asked to solve this expression up here at the top, and you can see that that reduces to 12 root 2 plus root 3. So just be careful when you're solving radical expressions that involve addition and subtraction, that you take a good look at the mixed radicals you're given, because you may be able to reduce some of them a little bit and then come up with some like radicals, which then do combine with addition and subtraction.